So this question says, let f of x equal 2x squared plus 6x plus 1. And we want to determine the average rate of change as x ranges from 1 to 4. Well, that in essence is a slope. So let's talk about it. I need to determine what is f of 1, and I need to determine what is f of 4. So f of 1 is negative 2 times 1 squared plus 6 times 1 plus 1. Negative 2 times 1 squared is negative 2 plus 6 plus 1, which is 5. F of 1 is 5. And then I need f of 4, which is negative 2 times 4 squared plus 6 times 4 plus 1. F of 4 is negative 2 times 16 plus 24 plus 1. F of 4 is negative 32 plus 24 plus 1. I believe that f of 4 is negative 7. Let's quickly check that on the graphing calculator. I'll go ahead and I'll pull that up. A couple ways we can do this on the graphing calculator. If I go to this button, my y equals button, I can plug in the equation or the function. Negative button is down here. 2x squared plus 6x plus 1. And I want to see what is the value of the function at 1 and what is the value of the function at 4. So I could say vars, y vars, function, y1 evaluated at 1. I hope it's 5. And it is. Vars, y vars, function, y1 evaluated at 4. And I hope that's negative 7. And it is. So how do we find the average rate of change? So in essence, I have these 2 points. My starting point is 1, 5. My ending point is 4, comma, negative 7. The average rate of change is the slope between those 2 points. Equals the slope, which is y2 minus y1 over x2 minus x1. So what is that? Negative 7 minus 5 over 4 minus 1. Negative 12 over 3, which is negative 4. And then we want to find the equation of the secant line. But let's go ahead and draw this parabola and those 2 points so we can see it. And then we'll go ahead and construct our equation of the secant line. So what am I going to do? I think I am going to go ahead and load Desmos. I'm not sure it's loaded. Now it is. So we'll go to Desmos. And I want to graph this function, which is f of x equals negative 2x squared plus 6x plus 1. There it is. And I'm interested in the point 1, comma 5, which we see there. And I'm interested in the point 4, comma negative 7, which is going to be a little harder to see, but there it is. So the secant line is the line from this point to that point. So I need to get the equation of the line. So I know the slope, right? The slope is negative 4. I have that. So you could use point slope form, and you could say y minus y1 equals m times x minus x1. I know a lot of students like this. So you could say y minus y1. The point I'm going to use here is 1, 5. And you could say y minus 5 is m is negative 4 times x minus 1. So just going to go ahead and put that into Desmos. And I'll show you my preferred way to do this. So using point slope form, again, y minus 5 equals m equals negative 4 times x minus 1. And there's the secant line going through those 2 points. But I really prefer to use slope intercept form instead. So if I have these 2 points, right? If I have m equals negative 4, and I have the point is 1, comma 5, I like to find the y-intercept. I like to say y equals mx plus b and solve for b. So I will let y be 5, m is -4, x is 1 plus b. So we get 5 equals -4 plus b. Adding 4 to both sides, I get 9 equals b. So I have m equals -4, and I have b equals 9. And then I use y equals mx plus b. That's what I prefer. It's also in function form. Y equals -4x plus 9 is the equation of the secant line. So let's go ahead and put that in Desmos. So I will turn off the first version, the point slope form, and I will turn on another version, which will be y equals -4x plus 9. And indeed, there's the equation of the secant line that goes through those 2 points using the average rate of change as the slope of that secant line.